Massachusetts. We've got a session on the adventures of an Android developer in iOS land by Cheng.
Hey, so my name is Cheng, and I'm a mobile developer at A6 Digital in Boston, where I work on the Runkeeper app on Android and iOS. Runkeeper is a fitness app that helps users train for and track their runs. At A6 Digital, mobile developers are rather unique in that they're expected to be able to program in both Android and iOS, but most folks tend to have one that they're stronger in. And for me, it's Android. But I knew that at some point, I was going to have to jump in the deep end with iOS. And a few months ago, that point came about with the introduction of the My First 5K feature, which is a series of audio-guided running workouts to train a user who's never really run before. So think couch to 5K, but like 100 times better. Shameless plug, if you're a complete beginner and you want to get into running, you should totally check it out. Unfortunately, it's not available on Android just yet. We decided to implement it on iOS first, which is why I'm here, which is why I'm now giving a talk about iOS at an Android conference. Don't worry, I'm going to make this work. So anyways, with that journey into iOS land, I definitely went through the expected learning curve. I picked up a lot of tips and tricks that, looking back, I wish I'd known beforehand. And so I decided I would collect all these thoughts into a survival guide of sorts to help other Android developers who are trying to ramp up in iOS in a short amount of time. So each slide in this talk, I'll provide you with a pro tip, a helpful resource, or if nothing else, just a cautionary rant. After this talk, you'll hopefully be able to avoid or at least be aware of some of the pain points surrounding developing in iOS as an Android developer. So let's get started. We'll start at the beginning. So you're excited, you have your MacBook ready. Oh yeah, in case you didn't know, you'll have to have a Mac if you want to do iOS development. That's because you'll need to use XCode, which only runs on Apple's OS. To get XCode, don't download from the App Store. I mean, you can if you're just like working on your own as your own project, but it's not a good idea if you're working as a team. And the reason is you don't always want the most recent version of XCode, which may contain changes to Swift that are breaking. So just avoid dealing with the App Store altogether for XCode downloads. It'll keep nagging you with automatic updates, and you don't want to deal with that. So instead, download XCode manually from developer.apple.com/downloads. This will, 1, prevent accidental upgrades that your team is not ready for, and 2, allow you to install any version side by side that you want. This way, your regular development work can happen on the XCode version that you already have, and then the work to migrate to the changes in the latest XCode can be done in the latest XCode. And this way, you're not blocked in your development every time a new version of XCode comes out and breaks everything. Another tip is if you are downloading multiple versions, make sure you rename the file before dragging it to your applications folder, or else that's known to sometimes cause issues as well. So opening your project. You're like, what do you mean opening your project? How hard can that be? Well, the first time I cloned and opened the Runkeeper iOS repo, it was really frustrating. I could not understand why I was getting like a boatload of errors. And it turns out the reason why it couldn't build was because I'd opened the Runkeeper project file, which is runkeeper.xcodeproj, instead of the workspace file, runkeeper.xc workspace. So what are those? Well, in Xcode, a workspace is a collection of projects, and then within this workspace, the projects can reference each other. I'll talk a lot more about CocoaPods later, but CocoaPods is an example that makes use of workspaces. So if you look at the Runkeeper workspace on the left, it's composed of the Runkeeper project and then the pods that it references. So pods are the various frameworks and libraries that your project uses, which is why you have to open runkeeper.xc workspace. You can open up runkeeper.xcodeproj just fine, but then you just won't build. Okay, so Xcode itself. Some days I feel like Xcode is really no better than a plain text editor. And that's because I end up using the search and path function in Xcode a lot. So if I'm just doing all these text searches throughout a project, then how is that any better than using a plain text editor? So for example, let's say I'm trying to inflate a layout for an activity, and I want to quickly navigate from the activity to the layout XML. In Android Studio, I just command click on that layout name, and it navigates me there to the associated XML file. You can also right-click and do find usages. But in Xcode, you end up doing a text search throughout the whole project to find that storyboard or nib file, which is not great. Other annoying things, refactoring code is prone to errors. And in fact, I only learned that it's only a very recent feature that you're even able to rename Swift properties. Before that, you had to search in path. And that just is beyond insane to me that an IDE would not have that basic capability until Xcode 9, which was released last year. So yeah, what else? Xcode has no safe delete feature that Android Studio does. So usually we just delete a reference, wait 20 minutes for the build to build, and then see if there are any errors. No idea why that would happen. Autocomplete is notoriously unstable to the point where it would just stop working for weeks. And then another minor thing that nevertheless drives me bananas is the matching braces in Xcode. So in Android Studio, if you click on an open brace, then it'll highlight where the closing brace is, right? So you know where that block of code starts and ends. Android Studio does this, and basically every other IDE will do this, except for Xcode. So in Xcode, if you click on an open brace, it only highlights the closing brace if it's within view. If your block of code is really long and it goes beyond the screen, it will not highlight that for you. But when do you think you would have the most use for finding the closing brace? How about precisely when that block of code is too long for you to see all in one space, right? Yeah, it's ridiculous. I've asked other iOS developers about this, and none of them knew about this super secret trick that I discovered. So very recently, I only discovered it very recently, and that is that you have to double click on the brace. And then it will highlight the entire code up to the closing brace. No one I knew thought to do that, and so that just goes to show you how intuitive that is. So if you take anything away from this long-winded Xcode rant, it's that you can double-click on a brace to find the matching brace. It's kind of fixed in Xcode 10 with cold folding, but I'd rather be able to see the whole code block rather than have to toggle it open and closed every time. So. All right, let's switch gears and talk about stuff you already know because you're an Android developer. You already know a lot of stuff about mobile development. You just kind of need to match the Android concept to the corresponding iOS concept. First, if you're developing in Kotlin already, you're already used to dealing with null safety. But the first time I really had to deal with them was in Swift. It's pretty straightforward once you get it. You kind of just have to figure out when to use optional chaining versus if-let versus guard-let. And I linked to some of the better explanations for dealing with optionals here, including the official Swift docs, which are actually pretty good. Lifecycle methods. Lifecycle methods work more or less the same in Android and iOS, and that was nice. So you can see how they map to each other here. Protocols. I remember browsing through the Runkeeper iOS database or code base for the first time and seeing all these instances of delegates everywhere. There's UI table view delegate, UI picker view delegate, just everything in iOS's UI kit had a delegate class. And it wasn't immediately clear to me that these are just protocols. These are interfaces, so they're called protocols in iOS. So you would just treat them the same way you would treat UI listeners in Android. So for example, if your Android activity had a number picker, and then you'll need to have your activity implement number picker dot on value change listener so that the number picker can interact with the activity when the value in the picker changes. You need to override all those methods, right? Same thing with delegates in iOS. If you have a UI picker view in your view controller, then you need to have your view controller extend UI picker view delegate. and then implement all the methods that the UI picker view is going to need in order to interact with the view controller. So same thing. Another reason you'll see the delegate pattern used a lot in iOS is because there's no concept of start activity for result and on activity result. It's not a thing in iOS because there's really, the navigation in iOS is just done totally differently. So instead, we use protocols to send information back. So let's say we have a view controller 1 and a view controller 2. When we dismiss view controller 2, we want it to send back some information to view controller 1. So what you do is you create a protocol like view controller 2 delegate, and then you have view controller 1 implement view controller 2 delegate. This way, view controller 2 will have a reference to view controller 1 as view controller 2 delegate, and then it'll just call, hey, view controller 2 delegate, do this thing, and then pass whatever information it wants to the method parameters. Okay, layouts. Let's take a quick poll. When building out layouts in your layout resource folder, how many of you use the drag and drop layout editor in Android Studio, like thing on the left? Cool. And how many of you use just the text tab where you type out the XML yourself? Yeah, exactly. So as Android developers, we're totally comfortable writing out layouts in XML. And for me, I definitely like it because I have better control over exactly what I'm displaying. Like, I could use Android Studio's layout editor, but like the key difference is the layout editor isn't the only way for me to edit layouts. I can always switch over to the XML view and then edit the XML myself. Not so in Xcode. So building layouts in Xcode is entirely visual. The layouts themselves are either nib files or storyboards. Their main difference is that the storyboards can span multiple screens and then have navigation between them. But regardless, you'll be using Xcode's interface builder and doing a lot of dragging and dropping. And the funny thing is, I see this with my counterparts in the office. So like we have iOS devs working on Android projects, and I see them, like dragging and dropping their constraints and selecting attributes in Android Studio. And I'm just like, no, just type it out already. But hold on. If layouts in Xcode are made visually through drag and drop, then what ultimately gets saved in source control? So what ultimately gets saved in source control are these generated XML files. But because it's a generated XML file, it's basically impossible to understand with like gibberish ID names, as you can see in this screenshot. No one ever edits this XML file directly. Just trust me, it's not something that is feasible to do in Xcode. So yeah, Xcode is very visual. And if you're visually inclined, that's great. I think that's why folks who might be new to mobile development might find it easier and more enjoyable to use Xcode, because the actual experience of creating layouts in Interface Builder is pretty slick. But I'd say there are 3 major problems with creating your layouts this way. 1, the hiding of information. 2, merge conflicts. And 3, reviewing PRs. So the first problem with being very GUI oriented is that it can hide information. There were so many times where like a layout doesn't quite look right to me, and I'm trying to figure out why, and it turns out like one of the views had this one obscure checkbox checked off in like one of the 6 tabs in the utility bar that I had to scroll through. And especially if when you're new to iOS, you can't possibly know all the different options you can select or check for a view. And it would just be easier to type out exactly what you need for a given view. It's bad enough when you're creating new layouts, but when you're trying to edit an existing layout, it is not a trivial thing to figure out what is all happening with all the connections in the drag and drop interface builder. And that leads to the second problem with drag and drop layout creation in Xcode. If you have more than one developer working on the same storyboard, the merge conflicts can be a nightmare. So like I said, storyboards are like the ones shown here. It's like allows you to really design the layout for multiple screens and then include segues to show the navigation for them, all in one file. And it's great for designers because you can usually see the complete layout and the navigation between them. But it's not great for developers because think what's going to happen if multiple people are touching this one file. You'll have to squint through the generated XML gibberish to figure out what to keep when resolving merge conflicts. It's okay, for example, for like storyboards that are very closely related. So like, for example, an onboarding storyboard that contains all the screens and segues related to onboarding a new user. But yeah, so that way it reduces the likelihood that more than one developer is working on a given storyboard at one time. But yeah, you do not want to have your entire app in just like one storyboard. Limit the scope of your storyboards. A similar problem arises with PRs. Like when reviewing PRs that have storyboard changes, it's impossible to understand what the diff is. And like I'll see a storyboard diff in someone's PR, and then I just basically assume that it's correct because nobody wants to have to look at the generated XML. Dealing with layouts in Xcode is such a pain that many iOS tutorials actually choose to program the layouts 100% in code. So no nibs or storyboards, just to avoid having to deal with them. So let's get a little deeper into iOS coding. The very first thing that quickly became apparent was that coding in Swift was far preferable to coding in Objective-C. Syntactically, it's cleaner with nice closures instead of god-awful block syntax. There's type inference. You don't have to create annoying header files like you have to do with Objective-C. And then the learning curve, I'd say, is much smaller for someone who knows Java or Kotlin. If you're starting a new app, great. The choice is obvious. And in fact, you can space out for the next few slides that I have about Swift and Objective-C interoperability. But if you're like me, trying to work with an old existing app like Runkeeper that has a lot of legacy Objective-C code, it was definitely a huge source of confusion initially. And so here's some resources that helped. It doesn't matter how many times I see block syntax in iOS, it still doesn't make any sense to me. Okay, so this topic just makes me shudder, and I think it's a common sentiment. The way interoperability is intended to work is like this. So in order to use Objective-C classes in Swift, you need to create a bridging header, which is just a file with a list of all the Objective-C classes that you want to be able to access in Swift. On the flip side, if you want to use Swift classes in your Objective-C, you need to expose your Swift classes or methods with an @Objective-C annotation so that your Objective-C classes can access them. Then in your Objective-C classes, you need to import the generated file. That is, so in our case, it's runkeeper-swift.h. You want to import that into every one of your Objective-C classes that uses your Swift, that needs access to Swift classes. So I have a link that describes it in more detail there. So based on what I just described, interoperability sounds pretty easy, right? Wrong. You can run into a whole lot of issues with it. So first of all, the renaming of methods is definitely more annoying than it is with Java Kotlin interoperability. So for example, let's say in Runkeeper, we sometimes want to deep link to our sister app, which is A6 Studio. If the user already has A6 Studio installed on their device, then we want the deep link to open to that app. And if they don't have it installed, we want to deep link to the App Store. So in Swift, I have a URL opener class. It takes in the URL to open the A6 Studio app, as well as the URL to the App Store. So as you can see, I annotate it with the Objective-C annotation so that my Objective-C classes can access this method. So now I'm ready to call this method in Objective-C. And this is where it gets weird. So my Objective-C class won't call the method launch app or store per se. The launch app or store method will get renamed in Objective-C to be launch app or store with scheme name. That conforms more to the typical Objective-C style of naming methods, and that's how I would invoke it. It's gross. Like, that's Objective-C for you. So anyways, how do you know what the method gets renamed to? Because that's not something you have control over. Like, you can sort of guess, but if you want to know for sure, you'll need to wait 20 minutes for XCode to finish indexing, and then you can open up the runkeeper-swift.h file. You can't actually open that file directly, but pro tip, if you command click on any of the import statements for runkeeper-swift.h that you have lying around, you'll see the list of what all the Swift methods got renamed to. Debugging. So in Xcode, debugging area gives you like a variables view on the left and a console view to the right. I generally don't use the variables view actually because it gets confused when you have optional binding and can give you unexpected results. Instead, I use the console pretty extensively. And the main command that you really need to know for the console is just print object, or PO, followed by the variable name. Libraries. So we Android developers can rely on Gradle to manage our third-party frameworks for us. Xcode doesn't really handle that for you. Like, the equivalent in Xcode would be CocoaPods, but CocoaPods aren't really integrated into Xcode as much, so there's quite a bit that you have to manage yourself when using them. So you have to edit the pod file, and then you have a separate terminal to running that you use to call pod install. And then when you add a new pod, it ends up in the pod folder that's generated, and a team has to make the decision of, do we want to commit that to the repo or not? And the benefit of committing that folder is that after you clone the repo, you can immediately open it and run. We chose to go that route with the downside of being that it sometimes leads to complex merge conflicts when dealing with different pod versions. It's just much easier to have Gradle handle all the syncing and building for you within Android Studio. And then any merge conflicts that do arise would basically be limited to that single line of change that you made in the library for build.gradle. A really helpful explanation on the difference between pod install and pod update, you can check out that link. Unit testing. So how many folks have unit testing in their Android projects? Oh, I kind of expected more. How many of you then use the Mockito library to help you with mocking objects? Cool. I feel like there were more hands that went up the second time. I'm not sure what that was about. But anyways, it makes life a lot easier, right? I certainly think so because after writing unit tests in Swift, there's no Mockito equivalent in Swift. Because at a fundamental level, Swift does not allow you to do reflection the same way that Java and many other languages do. So there's some libraries like Cuckoo that allow you to sort of do some of the things that you would want with mocking, but it's not nearly as powerful or reliable as something like Mockito. And so we don't use it at Runkeeper, but if you want to check it out, I have a link there. So what you have to do is mock all the objects yourself. So every class that you have that you want to mock, so for example, running packs manager, you'll need to create a mock running packs manager class and then override each of the methods so that they do what you want them to do rather than what they actually do. It's a lot of work, but it's not all bad. So for instance, one benefit is that writing out all of these mocks yourself is that you have full control over it. And so if you run into any errors, you know that it's something you did, not something that went wrong with the library that you have no control over. Okay, so let's say you finished your development work. Now what? One thing that I was surprised to learn was that you don't have the freedom of just handing someone your app like you can with Android APK. It's not that straightforward in iOS. You have to create provisioning profiles which add specific device IDs to the list of ones that are allowed to develop or test your app. Luckily, I didn't have to deal with too much of the setting up of provisioning profiles. We have an automation engineering team that usually handles any issues that come up with that. So as a result, I don't really have a lot to offer in terms of insight on provisioning profiles. But I think one of our iOS tech leads summed it up pretty well when the most helpful advice he could offer on this topic was to seek help. In conclusion, it's not very straightforward to give your app to someone to test, which certainly does make things safer. But yeah, it's one reason iOS developers use simulators much more extensively. You're probably aware that one of the most time-consuming issues with Android is the bazillions of screen sizes and OS versions that you have to support. Not true with iOS, so that's a good thing. There's really only a handful of screen sizes that you have to test on. There's a very high adoption rate with new versions of OSs, so it's mostly because how annoying Apple is with their upgrade messages and continually prompting you to upgrade until you finally do. So that means that you have to test your app on fewer versions of the OS, so you get your app ready to release sooner. But not so fast. So the amount of time you spend regression testing will be reduced, but when you factor in the amount of time that your app will spend waiting approval in the store, it ends up canceling out. So unlike Google Play Store, every release to the App Store requires Apple's approval before you can let it go in the wild. You can get rejected for various reasons. For us, releasing Runkeeper to the Apple Store takes about more than a day. Like, it takes a few hours to process it when you upload it, and then it takes a little more than a day to be approved, and then you can submit. So you're not used to waiting as an Android developer. So that's all I got. We covered downloading XCode to submitting your app to the App Store. But in between, there are a lot of other iOS issues, a lot of things that could go wrong that we just didn't have time to cover. If you have other tips or tricks to share, please reach out. Thank you so much.
So we do have time probably for a couple quick questions. Does anybody have any off the top? Yes, thank you.
So what are the good things about going from Android to iOS?
Yeah, so like I said, definitely the fewer versions that you have to support, the fewer screen sizes that you have to support. It's such a relief. Like, it's going from literally like a gazillion to just a handful, and it's great.
Does XCode have any advantages over Android Studio?
In terms of like,
Anything?
honestly, I really can't think of any. Like, a lot of developers will try to avoid Xcode. So there's this other app that's written by IntelliJ that is an IDE for iOS. The problem is it doesn't do layouts. Like, Xcode is the only thing that allows you to do the layout. So if you want something closer to IntelliJ, you could use that app. But as soon as you start trying to make layouts, it'll direct you back to Xcode. But you can get all the other benefits of IntelliJ's IDEs if you use that app.
One more question.
So this is, my question is less specific about the comparison between iOS and Android, and more about your experience in iOS working with views in your app. Like you mentioned, a lot of companies have just chosen to go with programmatic views in iOS. Have you guys been playing around with that, or do you guys still prefer storyboarding?
We have still been storyboarding, but I know a lot of other places have gone full coding.
Do we have one other quick question? One over here.
So are you now switching to iOS or are you waiting on the
Oh no, well, like I said, we have to change back and forth at A6 Studios, so we have to be fluent in both.
All right.
Yeah.
Cool. All right. Let's wrap there. One more time.